Everything produced by mankind has a lifespan, but when that span is complete, it's often not the end, but just the beginning of a whole new existence. From destruction to renovation to transformation, this cycle of life, death, and rebirth happens in amazing places called boneyards. They are the largest moving objects on land, and one of the most powerful machines ever constructed, trains. With over 100 cars joined together stretching over a mile in length, they can move tons of material at speeds in excess of 70 miles an hour. They ride on almost 100,000 miles of steel rails that literally crisscross the nation. To service this vast system and these gigantic machines, an equally huge complex of railroad boneyards have emerged. Imaginative entrepreneurs have found new and innovative uses for every single component of the railroads, from tracks and ties to the trains themselves. Though most of these great iron horses will ultimately be ripped and torn apart for scrapping, their parts and metal recycled, some will endure for many decades, while others will be grandly restored to live on in other, sometimes surprising roles. All in the finest traditions of the boneyard. By the mid-19th century, the Transcontinental Railroad was America's greatest engineering accomplishment. More than any other industrial system, the railroads fueled the rapid expansion of America's economy and the growth of its population. So powerful is railroading's impact, it's been said that America is bound together by ribbons of steel. Those ribbons are the steel rails that trains run on. Their basic components are simple and rugged, steel rails and wooden ties to bind them together. Their simplicity and rugged construction meant they could last for decades. But eventually, even ties and rails need to be replaced. In the high desert near the California-Nevada border, a company called Jim Dobus Incorporated is clearing and salvaging a 20-mile stretch of track, abandoned because it is no longer needed.
Depending on if industries are changing, closing down, they'll remove different lines. These are normally not main lines. These are what they call branch lines, and so they're not the main line. But yeah, it happens quite a bit.
Constructed in the early 1920s, this stretch of abandoned branch line was made of standard 39-foot steel rails that weighed 110 pounds each and wooden ties created from a variety of woods. Founded 30 years ago, Jim Dobus Incorporated is now run by Jim's son, Don.
The first thing we do is we unbolt the rail, then we unspike it. We set the rail off the track, off the ties. Then we take a magnet and we pick up all the track material, plates, spikes, bolts, angle bars.
Called OTM, other track material, it's the variety of iron parts that attach the tracks to the ties and the tracks to each other.
The track plate goes on top of the tie, the rail sits on top of the plate, and then the spikes go down through these holes and hold the rail to the tie and the plate. The angle bar joins the two pieces of rail. When you bring two pieces of rail together, the angle bar joins those and the bolts go through it.
One of the curiosities found on this job were date nails. In the past, selected nails were stamped with dates and hammered into the ties when the tracks were laid down, so workers would have a guideline as to when they needed to be replaced. The rails are then set aside, ultimately to be sold to a variety of boneyards, to be transformed into everything from bed springs to fence posts. In earlier times, both ties and rails were replaced by hand with hand tools. Now, workmen remove the ties with this machine. It's called an excavator with grapple.
Well, we use the fixed grapple on the excavator to remove the ties from the bed, shake the debris out of them, and set them on the dump truck to take them into the tie yard where we sort them and grade them.
The excavator has a 20 to 25-foot reach and weighs between 5,000 and 6,000 pounds. Its grapple can tear a railroad car apart, demolish bridges, or perform any heavy-duty task needed. It's also fitted with a special piece of protective equipment.
It's a cab guard, and it's used to protect the operator from any flying debris that might come back at the cab and break the glass, or get in the cab with the operator.
On good days, workers can scavenge between 1,000 to 1,500 old railroad ties. For these ties, this is hardly the end of the line. In previous years, old ties usually ended up in landfills or were bought by nurseries for use in landscaping. But today, Many are sent to places like RTI Railroad Services of Utah. Founded 30 years ago by Charles Jacob, it's a family business that includes his sons James and Joseph. RTI has 132 railroad cars in its fleet. With each carrying about 1,000 ties, a total of over 132,000 can be shipped in every month. Ties are brought in here from all over the West and processed for a relatively new and unusual purpose, as fuel for electric generating plants. The first part of the process is to remove any stray metal from the wooden ties.
Behind me here, the shredder is breaking up the whole railroad tie, and any metal that might be in with the railroad tie, like a tie plate, will be broken out, and the magnet that's on the machine across the belt will pick up the metal.
And that scrap metal is simply recycled at different steel recycling facilities in the United States.
The ties themselves will then be shredded and ground in a multi-stage process for more efficient burning.
We have a grapple that puts the ties back into the shredder. From the shredder, they go into the grinder and grinds it up into a little bit finer piece so they can burn it at the power plant. Just burns a lot cleaner, a lot better.
Once the shredding and grinding process is complete, the end product is ready to be shipped out for the final phase of the railroad tie's amazing journey. Honey Lake is one of 28 power plants in California that use biomass fibrous wood waste to generate electricity. Honey Lake receives approximately 8 truckloads, equivalent to 200 tons of chipped ties per day from RTI. This amounts to around 20% of Honey Lake's total consumption.
The ties that we use are ties taken out of service after an average life of 30 to 40 years. We receive on the order of a little over 500,000 ties per year.
The ties are first weighed and dumped from the delivery trucks.
And we call them truck dumps. Very simple. We have conveyors, we have hoppers, we have front-end loaders, which are tractors that move the fuel around and manage the piles. We have bulldozers that do the same thing. We have reclaim devices that accept the fuel from inventory and pull it back onto conveyors, which return it to the boiler. Those are the basic pieces of equipment we use.
The chipped railroad ties are then blended with other fuels and burned to heat the power plant's boilers. At this point, Honey Lake acts simply like a conventional power plant, boiling water to create steam, to drive a turbine, which drives a generator, which produces electricity.
When we're running full load like we are today, we're generating 33 megawatts of electricity, and we transmit the power from the plant here to Susanville, which is 23 miles away.
From railways to electricity, the final journey of these worn-out railroad ties translates to power for 30,000 average American homes. But for the steel rails salvaged with these ties, it's a whole different ballgame. They're going to one of the largest mills in the U.S., Chicago Heights Steel in Illinois. In this vast boneyard, thousands of steel rails, some over 100 years old, have been collected from abandoned rail lines all across the nation. In a century-old process, they wait to be transformed by fire into fence posts, the kind that support wire fences from coast to coast. The product looks as simple as the rails, but the process of producing them is surprisingly complex.
The plant was built in 1893 to convert a used piece of railroad rail without melting it, just by reheating it into a finished product.
They call their method re-roll.
We consume 150,000 tons of re-roll quality rail for the operation.
The rails are moved into the mill where the re-rolling process takes place. The first step is to soften the metal by heating it in furnaces to over 2,000 degrees.
To bring it down to layman's terms, when your mother and grandmother had to make noodles, they took the dough and they took a rolling pin and they rolled it out. Basically, what we're doing is no different than that. Once the rail is heated to 2,050 degrees, it becomes pliable. Not melting stage yet, but it becomes pliable.
Once the rail reaches this pliable temperature, the operator signals for the rail to be pushed out of the furnace. From there, it goes into a high-pressure water container. 7 water jets operating at a pressure of 1,500 pounds per square inch blow off any debris on the surface of the rail. The rails are then moved to the first in a series of rollers. These split the rails into 3 different sections, creating the raw fence posts. Jesse Knox then adds the finishing touches.
It's just a raw post when I first get it. I send it through the straightener, then I put a plate on it, which I hang it up, send it through the paint, through the oven, come through, and then we package them up, as you can see behind me.
The final product of the re-roll process, brand new fence posts. Lots of them.
I do about 20,000, maybe 20 to 24,000 a day.
In addition to fence posts, Chicago Heights Steel uses re-rolled rails to make everything from bed spring angles to garage door openers to posts for traffic signs.
Well, fence posts are bread and butter. It still amazes me that we make them. You would think we probably make 22 million of them a year. We do that every year, year in and year out. And every place you go in the country, you see them. It's like a never-ending product that we make every day, 6, 7 days a week here.
All this from a boneyard of cast-off rails.
Hopefully, everyone who is watching this program gets an idea that there is life after death. Normally, you know, that railroad rail would be melted down and it's dead. But now, here it's come back as a garage door tee, as a signpost. So, I mean, we saw a rail out there that was over 100 years old. So, the rail that was 100 years old, we took it out of the wheelchair and we've made it a new, young, whatever the finished product was.
While operations like Chicago Heights Steel are all about transforming cast-off rails into something completely new, there's another railroad boneyard where locomotives face their own kind of transformation. The crews of Steel, etc. display their expertise in the precision dismantling and destruction of locomotives and rail cars. Usable parts have salvage value, and the sheared metal generates revenue as furnace scrap. One of Steel, etc.'s primary jobs involves cleaning up train derailments, both on-site and back at their main yards.
These two locomotives here were involved in a head-on collision with each other. And while the outsides of them look relatively straight and okay, the internal damage was so bad that the value of it basically was decreased to the point that they were only worth salvage at this point.
Specific items must be protected during the violent process. To tear down the locomotive without damaging the valuable parts within, the process must be careful and precise.
This is a diesel-electric locomotive. It has a diesel engine that runs a very large generator, and that, of course, requires a lot of copper wiring and non-ferrous metals, and that stuff has to be removed from the iron before we can ship to the mill.
When items need to be removed, the men go in with hand torches and wrenches to free bolts, cut wires, and set chains to lift them out. Shears slowly peel away the metal skin as cutting torches release the parts marked for salvage, carefully removing them and setting them aside.
The shear operator needs to be able to determine which items can be sheared up and which items need to be cleaned a little further. And a good shear operator can separate those two things out with that shear head. Even as big and heavy as it is, they can do very delicate work as well.
This constant shearing, exposing, and removing will keep Jeff and his crew here for more than 6 months. As a teenager, Bennett started working for salvage companies in the Northeast, and scrapping has been in his blood ever since. Today, like Jeff, each man in his crew is experienced and qualified to cover every need in the process.
Everybody on my crew is able to perform multi-functions, and the reason for that is if one man is busy or isn't here for the day, I don't have to shut my job down. So it's important to cross-train everybody so that they can run each machine, the cutting torch, and they all have a good understanding of the processes that we're going through.
Because of the extreme heft of the cars they demolish, the crews utilize the heaviest duty machines available. But sometimes success depends on human ingenuity. Moving this monstrously heavy engine presented a problem.
It actually took the combined lifting weights of both the 988 and the 962 in order to move it. That would put it in excess of 25 to 30 tons by itself.
The process will continue until these cars have been cut down and sent to their main facility in Great Falls. This Montana boneyard is the final resting place of old rail cars and machinery. The ancient equipment is transformed into valuable scrap metal using powerful, state-of-the-art shears operated by seasoned professionals. Joe Flipowitz is putting their latest acquisition through its paces.
It's the third largest in production made by Stanley LeBounty. The one we have down at Livingston there is a MSD 70 LeBounty. The MSD 70 will go through 2-inch thick steel versus the 7500R will go through 6-inch thick steel.
The 7500 is rapidly reducing this old rail car down to a specifically designated size for disposal.
What we call a hopper car is what we're cutting up today. It'll go through that in about an hour versus where it'd take about 8 hours with our other MSD 70 shear. We generally have to cut it down to 3 foot by 3 foot, get it into the railroad box cart or gondola cart.
Joe Flipowitz is the second generation at Steel Etc., begun by his father Jim over 40 years ago. This boneyard is a silent history of the company's successes. Even the train scrapping machines themselves are being scrapped.
All the pieces of equipment up here in the salvage yard are pretty much ready for the scrap yard because they're old and the parts are getting kind of hard to find. But with the price of scrap iron right now, we're just trying to cut them up and recycle them.
While there's not much the new LaBounty shear can't handle, even the most modern of equipment is only as good as its operator.
One of our operators is Alex Flipowitz. He's been operating equipment for about 35 years. You can see what great kind of an operator he is, so he's very smooth.
Equipment of this type is expensive to purchase, maintain, and operate. Just the blades of the shear cost over $1,000 each.
Out of a blade, we can get about probably 50 hours or so, generally. When we're cutting these hopper bottom cars, they're so super thick, it just eats them alive pretty quick, and you have to replace them quite often. After so many hours, you have to go through and retrim the blades there, because if you don't, it'll just bend the steel instead and make a precision, sharp cut.
Once the train cars have been transformed into pieces that can be easily transported, they head for Steel Etc.'s main boneyard. Here, an even more powerful machine awaits them for further reduction.
We have a Sierra 750 shear. There's only 22 of them made in the world, and it's quite the operation.
The 750 is a 120-ton monster. It can shear up to 20 tons of steel per hour with a maximum operating pressure of over 4,300 psi.
We're picking up miscellaneous railroad parts and we're loading it into the 750 shear, where it's getting ready to be sheared up into smaller 1 foot by 1 foot sizes so we can put it in the railroad gondola car.
A Cat 350 material handler loads the cut-up railcar pieces into the massive 750 for processing.
You can control the size of the metal to 1 foot by 1 foot, 3 foot by 3 foot, and so on. We generally prep it down to size so we can get more weight in the car. Once the steel is compressed, you'll hit the automatic exertion button in the cab, and at the end, it has the shears that come up and down all the way through the process until it's done, and then we reload it with scrap iron.
This process continues on, taking one denizen of the rails after another and reducing them to rubble. Ironically, their remains will ride out of this boneyard in another rail car, heading for the foundry and rebirth. But there's another rail boneyard where, instead of facing destruction, old locomotives are restored, transformed to brand new condition. Amtrak, America's largest passenger rail service, owns over 270 locomotives and 1,200 passenger cars. At no time was the importance of this system underlined more forcefully than during the aftermath of the terror on 9/11.
On September 11th, if you recall, planes were grounded, and Amtrak was the only mode other than the automobile that was traveling in the Northeast Corridor, which highlights the importance of rail service in the United States.
Amtrak owns or operates approximately 600 facilities in 46 states. Amtrak's Beech Grove facility in Indiana is both its primary boneyard for old and damaged trains, as well as its principal renovation and maintenance facility. Built in the early 1900s, this boneyard is still going strong, repairing and renovating the entire fleet of Amtrak trains.
Beech Grove, the buildings were originally built right at the turn of the century. If you get a chance while you're walking around, you'll see on every building is a big date stamp on the front of it. I think this one is 1904, 1905 when this building here was built.
Beech Grove has 108 acres and 700,000 square feet under roof. We're about 3 hours from Chicago, and we're the hub of the inner city. We overhaul locomotives, cars. We do wrecks, car wrecks, locomotive wrecks, and we do remanufacturing of passenger cars.
One of the main functions of Beech Grove is to take worn and damaged equipment and completely restore it.
We basically bring in a unit that's been out on the road for about 5 years, close to 1 million miles of service, and bring it in, completely strip it, clean it, then we'll add any updated mods that have been changed on the unit since it was first manufactured, and then we'll completely reassemble it, paint it, and then we'll test it, and then hopefully we'll ship it back out and we won't see it again for another 5 years.
When a locomotive comes in the shop, it goes to the strip down area. The engines are removed and it's stripped down to bare steel.
At any given time, there are several dozen cars and a few dozen locomotives in various stages of repair and restoration. The workhorse of the system is the GE Model P42, which weighs 27,000 pounds and is driven by a 4,200 horsepower diesel-electric engine.
The GE locomotives that are maintained here and rebuilt here by our crews were made in Erie, Pennsylvania. We have almost 200 of this locomotive and a predecessor series too. So every one of these big monocoque style locomotives, which have huge diesel engines in them and some complicated computer systems for their maintenance and diagnostics that make electricity to power the whole train, come through here at Beech Grove. And the folks here do amazing work.
Gerald Scott is a third-generation worker at Beech Grove.
When my grandfather hired me in on the railroad, he lied about his age. He was 14 years old. He hired in 1906, and he retired with 50 years of service. My father retired in 1985 with 34 years of service, and now in 2006 we have 100 years of railroad time in the family. I have memories with my father. My grandfather died when I was 2 years old, and memories with my dad, he used to take me out on some of the road crews, and he had to work up by the Wabash River for 29 days straight, and he snuck me in up there to stay in the camp cars with him for a couple nights. It's pretty neat.
There are machines at Beech Grove that have also been working here for generations. One is a crane that's over 100 years old and so enormous that the building that houses it was built around it.
The largest crane is 135-ton crane, which was put in the building in 1904 as they were erecting the building, and then the building was finished in 1907. It will pick up a locomotive. We put in locomotive engines into the car bodies or the locomotive bodies with that crane, and whatever is too large for the 15-ton crane to pick up, we'll use the 135-ton crane for.
Well, the cranes that we have here at Beech Grove are the heart and soul of the shops. We usually use that for when we're picking up the unit, either to de-truck, which is take the trucks out from under the unit, or to re-truck or put the new trucks underneath it.
Trucks are the giant wheel assemblies and undercarriages of the locomotives. Lifting the locomotive makes them more accessible to the workers. To accomplish this lifting process, large pieces of metal called straddle bars are required. Hooks are lowered to pick the straddle bars up out of the floor and move them over the locomotive. Then they're lowered down on one side, attached, and the locomotive is slowly lifted. It's then held motionless until the worker's job is done.
The huge gears that are on the crane are unique in that they're large enough that they will hold a locomotive in the air, and they move at a pretty good rate of speed and are impressive in that their size and their ability to hold the weight of a locomotive.
After all the mechanical repair and restoration work is completed, trucks, generators, brakes, air conditioning, plumbing, and wiring, the last stop is the body and paint shop.
This is the paint booth here at the fabulous Beech Grove shops. This is where the locomotives are painted after we do the prep work in the prep building. I do the body buildup work prior to the paint. We get wreck work in, they do the wreck work, replace body panels in the diesel shop, and then they bring it to us and we do the body buildup with the Bondo and prepare it for the paint.
It's all part of the highly complex maintenance and repair process to keep the trains out of the boneyard, on track, and running smoothly.
There is more to running trains than most of our passengers see. It should be an invisible experience. They hop on the train, the air conditioning works, the lavatory systems work, the dining car systems work. They should get on, lean back in their seat, and enjoy the experience. It's more than just steel wheels on steel rails.
With all the constant repair, restoration, and renovation, the safety of passengers and property is always on every railroader's mind. To answer this crucial need, an experimental facility has been designed to operate as an extraordinary boneyard, where trains are even destroyed to save lives. Unlike traditional repair yards such as Amtrak's, where old or broken trains are sent to be restored to service, there's a special boneyard where trains are sent to be damaged. In the high desert 20 miles outside Pueblo, Colorado, stands TTCI, Transportation Technology Center, Inc. Using old and sometimes damaged locomotives and rail cars donated by the railroads, scientists, researchers, and hazardous material experts at Pueblo work to make railroads safer. It is in fact the world's leader in research and development on railroad safety. Although rare, accidents still happen along America's nearly 100,000 miles of track. In 2005 alone, 1,125 incidents were recorded, everything from derailments and fires to small and large collisions. These accidents killed or injured 341 people last year alone. Almost every railroad man alive has a story to tell about an accident of some kind.
It was a derailment that they had lost their braking system, overloaded. And anyways, it ran away and derailed, and it derailed the whole train. It was going really fast and went into some houses, but it was very, very devastating.
Nevertheless, America's rail system is among the safest in the world, and one of the major reasons for this is the activities here at Pueblo. Covering 54 square miles, an area twice the size of Manhattan, Pueblo has over a dozen labs and 50 miles of track. One of the most impressive test sectors is the fast train, which runs on the HTL, the high tonnage loop. Components tested here help railroads analyze potential safety hazards caused by the massive loads carried by today's trains, which can weigh up to 400,000 tons.
We have a broken rail detector, which will detect a broken rail if we break a rail. Basically, we're testing everything as far as the rail, the ties, the cars, the wheels, just to test it for the high tonnage.
On this steel bridge, we have instruments that measure the strains in the member. How much does the load affect the member? Is that crack active? Is it growing? We're looking at sensors that can remotely detect whether or not the crack is active.
Such cracks are often caused by metal fatigue, small fissures that can appear due to constant use and repeated stress. If not found early and repaired, they can cause the structure to break, with disastrous consequences. Carrie Gonzalez's shop stands near the fast track ready for access to the Boneyard's trains, which serve as test beds for this new project.
Currently, we're working on an inspection system to detect fatigue cracks in axles. We use laser ultrasonics to produce high-frequency noise. We have 2 lasers enclosed inside of a bungalow, inside of a housing. Each substation consists of a mirror and lens. The mirror turns the beam vertical, and the lens focuses the beam to a line to propagate the surface waves across the axle.
In contrast to the high-tech lasers in Carrie Gonzalez's shop, another corner of Pueblo is home to what appears to be a decidedly low-tech boneyard, full of wrecked and damaged railroad cars. Yet appearances can deceive, because this is the location of one of the other main functions at TTCI, first responder training. A variety of cars are pulled from other boneyards to provide the realism demanded for this kind of training. Some have been wrecked, others have reached the end of their useful lives. Many are tank cars, because these are the most common carriers of hazardous materials on the rails today. Statistics report approximately 1.5 million shipments of hazardous materials in the U.S. every year, such as oil, gasoline, and caustic chemicals. Here, responders are taught to recognize, isolate, and neutralize any toxic substances released during a railroad incident.
Basically, this program is designed to teach these people how to deal with emergencies that they're going to encounter on our railroad.
Firefighters, law enforcement personnel, and employees of chemical companies come from all over the country to learn how to manage a toxic spill.
They're going to have to deal with this emergency for some period of time because outsiders are not going to be there right away. So we're trying to get them knowledgeable and develop some skills and give them some experience in dealing with the emergency.
Right now we have well over 60 to 80 rail cars that are set up in different scenarios, either for transfer operations or in actual derailment scenarios.
To simulate a derailment, cars are hauled out to the open desert far from any track and laid on their sides, so instructors can safely set fires and explosions, and students can have plenty of room to work the site. Different scenarios are played out, and tonight, the instructors are making it as intense and dramatic as possible.
We'll have smoke generators to simulate vapor clouds coming from cars. We'll have fires behind some cars to simulate a breach of a car where the contents may have breached, ignited, and have them go through the decision process of, do we actually extinguish the fire, or is it better to go ahead and let it burn?
The trainees carefully maneuver around the tank cars, trying to determine the hazardous threat and, if possible, neutralize it.
We show them basically the configuration of the valve arrangement, identify the leak, and with them side by side with us, we actually go through, walk them through the proper repair procedures for that particular problem, and then finally turn them loose and let them do it on their own.
There's only about 10 minutes of air in their oxygen tanks, so the students must be thorough yet quick in repairing each leak. To be prepared for the dangers and railroad emergencies, this kind of intense and realistic training can only be achieved in a boneyard like Pueblo. Raris Railway of Montana is a living example of a 19th century working railroad. By carefully maintaining its locomotives and rail cars that otherwise might be in a boneyard, Raris still functions today as it did when the original line began over 100 years ago.
Our trains are, I guess you could say, they're recycled. We purchased them from the former owner. When they no longer have any value to us, we'll sell them for scrap. They're quite old, so they're either parked here for historical purposes or for our own use as we service our line.
Although the mining industry of Montana has diminished considerably since the 19th century, this area is still a major supplier of copper concentrate. Mined by Montana Resources, Raris hauls this concentrate from the mines in Butte to the main lines for shipping to smelters where the copper is extracted.
The service that we provide to them is bringing in the empty cars so that they can be loaded with the concentrates, and then once they are loaded, taking those loaded cars back out to an interchange point so that they can be shipped to whatever location the customer is at.
To haul the copper ore, Raris employs a variety of freight cars and locomotives. One of the line's main locomotives is the venerable EMD GP7. Built over half a century ago by General Motors Electromotive Division, these models are still going strong when thousands of others just like them have long since gone to the boneyard. Up until the 1950s, virtually all locomotives operated on steam power. However, in 1949, a more efficient system was introduced called diesel-electric drive, which is still used in most locomotives today.
The BA&P Railway discontinued using steam locomotives a good number of years ago and went to the diesel electrics that we have right here.
Each GP7 is driven by a 1,500 horsepower 16-cylinder diesel engine. The diesel engine powers an electric generator which provides 1.1 megawatts of electricity to the motors that drive the wheels. This diesel-electric drive system is far more efficient than pure diesel power. Since the electric motors are linked directly to each of the locomotive's 4 axles, this greatly simplifies maintenance and lowers operating costs. Electric drives also require no gear shifting. Varying the current and voltage to the traction motors controls both the motor's torque and its RPM, providing a smooth application of power to the wheels at all speeds. Between 1949 and 1954, over 2,600 GP7s were manufactured. Today, only a few hundred are left, making the ones at Raris boneyards on wheels. To help maintain its fleet of aging locomotives, Raris employs another artifact of a bygone era, a roundhouse. It was built at the turn of the last century and is still operating today. The 61-foot-long turntable stands before the roundhouse's maintenance bays. A train is driven onto the turntable and it rotates to shuttle the train into one of the bays for repairs and maintenance.
I think a sorting mechanism is a good description of the turntable. It allows you to position it so that you can get it where you want it. You can line it up to go in the direction you want it to go.
Roundhouses were invented in the early 1800s to switch the heavy locomotives onto other tracks for repair. This task is now accomplished in most modern rail yards by simpler track switching systems. But Raris still uses its roundhouse daily. In its enclosed bays, technicians are able to work on locomotives and other cars no matter what the weather is like. By using old and restored trains, Raris is kind of a boneyard in motion, demonstrating that, if properly maintained, railroad equipment can last literally for generations. While Raris is a living example of a 19th century cargo railroad, a very special boneyard focuses on another aspect of railroading history altogether: passenger travel. By the 20th century, railroads had become the preferred mode of luxury travel across the country. Royally appointed cars graced the likes of legendary trains like the Super Chief, the 20th Century Limited, the California Zephyr, and the City of New Orleans as they travel from coast to coast and all stops in between. But as air travel proliferated, this grand style of touring and traveling was very much forgotten. Until now. This modern-day boneyard belongs to the Colorado Railcar Company, which operates Grand Lux Rail Journeys, committed to restoring the grand tradition of luxury passenger rail service in the 21st century. It all starts with finding old cars to refurbish.
These cars are really in service today because somebody cared enough about the concept of luxury travel to save a few of them.
Grand Lux gathers old rail cars that have languished in other boneyards around the country. Their task is to restore them into elegant passenger carriers. But recreating that grandeur presents many challenges.
The challenge is to take a 50-year-old car and make sure that it is structurally sound.
The structural rebuilding of each car begins at its most basic component, the trucks.
They're the wheels, the axles, the big metal frame, or the truck frame, and that's what really connects the rail to the rail cars themselves. We can actually buy an entire old rail car, take the trucks out from underneath it, scrap the rest of the rail car, and rebuild those trucks and really give them a second life.
The truck assemblies were built to withstand the extreme rigors of carrying heavily laden rail cars. With proper care, they can last nearly a century.
Trucks are built very stout. Every 40 years, they're required to have a major overhaul. We deconstruct the truck completely down to the last bolt. We replace all bolts, clean all the pins. If any bad ones are found, they're replaced. Bushings are inspected. Every piece on the truck is totally inspected to make sure that there's no cracks, no flaws, nothing bad in them.
Once the trucks have been brought up to grade, they're reattached to the bolster on which the car will ride via the side bearings.
Side bearings come in contact with the car as it rotates around the curves and helps keep the car stable and level. The car sits on a bolster. The bolster transfers it through the springs into the truck frame, so the truck frame has the ability to have a little motion without moving the car. The springs take the vibration and make a nicer ride for the car.
The restoring continues with the refitting of basic structural components for what will become the luxurious passenger compartments. In doing so, the workers at Grand Lux must strike a delicate balancing act between old-style luxury and the demands of the modern world.
The real challenge we have is keeping that old-time feel and meeting today's safety standards. Those are things such as smoke standards and flame standards and crash-worthiness standards.
About 10% of our business is restoration. The rest is building brand new cars. And the exciting part about having that knowledge of the new cars is there's a lot of the new technology we can bring to bear on the restoration.
We really believe that you can learn a lot from the past and take great ideas from the past and just improve them to today's standard. Our best such example right now is our new DMU, or diesel multiple unit. The last time these were made in the United States were by the Budd Company back in the late 1950s. They're a self-propelled passenger rail car. So that means they're both a rail car for passengers and a locomotive in one. So we took a 1950s idea, applied year 2000 technology to it, and now we have a great new car that still has some of the same heritage and features that they were going for in the 1950s, but with the reliability and the comfort that we require today. We also have great challenge with systems integration. We need to keep the same amount of space dedicated to the heating and ventilation and air conditioning, but we need it to perform far better than it did when it was first designed. So we are really integrators of technology.
In charge of interiors for Grand Lux, from plumbing to electrical systems to woodwork, is Dan Frazier.
My area of responsibility with the cars is the interior package. Once the cars are built up to their steel structures, then we move in and we have that responsibility. I have 13 carpenters working for me, and we get into all kinds of different challenges, such as sheet metal, stainless. There are miles of wires and electrical components and circuitry, transformers, a lot of plumbing. When you walk through this car right now, you're going to see an elegant, highly finished car interior. It has all kinds of ornate moldings, crown mold, corbels, lighted buffet, very expensive wool carpeting. There's just a tremendous amount of wood effort that has been put into this car.
The tasks to make the interiors glow with luxury are varied and labor-intensive.
Most of the cabinetry we do here is just custom based on the customer's needs. Paul is making some very small hardwood frames. They are so thin that it's hard to get a mechanical fastener in them to hold them together. So what we've done is machined a slot in the back, as you see going on. Jeff was laminating doors to be fit into a cabinet, running the door through what we call the pinch roller, which puts tremendous pressure on the laminate and the door and bonds the glue tightly. That is going to be a conference room table that is going to be 16 feet long. What Randy was doing was mounting the strips around the table and inserting the granite slab to make sure everything fit properly. We have the capability to make just about anything that's required of us. Very rewarding.
The latest project for Grand Lux is a vintage dining car. This particular car was part of the Union Pacific line in 1949. It was built as a 24-seat diner with a 29-seat lounge.
As you can see, we have taken out a lot of stuff in the car, and we're going to refurbish the car and make it a formal dining car. One of the things that we're looking to do is to take the center area of the car and build it down with maybe with some fancy ornate wood moldings in that, and maybe put some backlight in there to give it a real fancy ambiance, if you will, for your dining experience.
Transforming something like this into something that looks like this requires a tremendous amount of care, skill, and dedication. But those are the specialties of the craftsmen at Grand Lux.
If you look over my shoulder and you see the blue cars back there, those were originally built by the Canada Car and Foundry Corporation back in 1955. We took those cars and we took a few of the main structural underbody components and we built completely new cars on top of those. So we used a few main structural components and rebuilt the trucks underneath them, and now they are underneath some of the luxury single-level dome cars that are running in Alaska and Canada. Even though the blue cars don't have any of the running gear and they're not fit to be on the rails anymore, we still use them every single day for additional warehouse storage. That's one of the advantages we get out of recycling these cars. We get the structure and we get to build new cars from the structure, but we also get thousands of square feet of storage space.
While one restored car is an impressive sight, many of them rolling down the track together is even more magnificent and expensive. This 18-carriage train cost over $15 million to restore. Polished brass in the sleeping cars, inlaid mahogany in the dining cars, and ebony, brass, and leather in the club cars are the line's hallmarks of elegance. Gourmet meals, fine wines, live music, and historians lecturing en route all add to the classic romance of these trips. It truly harkens back to the days when the rails provided travel accommodations for the ultra-rich.
Only the Astors rode in the kind of luxury that we have on Grand Lux today. This car didn't exist except for the Vanderbilts and the Astors and those people.
For the people at the Grand Lux Boneyard who actually did the work to restore the superlative train, it was much more than just a job. It was a passion for railroads. The same feeling that has thrilled millions across America for generations. The history and spirit of railroading lives on in boneyards like the Grand Lux. Here, the traditions of the past, the innovations of the present, and the promise of the future all merge together on rails of steel.